Okay, this is going to be an introduction to electron configuration. There's a lot to it. We're just going to cover the basics for now, just so that way you understand what I'm talking about when I say electron configuration and what it means whenever we talk about ions and why things bond the way that they bond. Now, yesterday you saw a model of an atom. And you saw rings in there, and those rings had different places for different electrons. That's because each orbit, each orbital, each shell, each ring has its own orbit. And electrons move in a certain way depending on what orbital they're in. What are you talking about, Miss Green? You're crazy. Well, this is what I'm talking about. Whenever you look at a periodic table of elements, they're set up in blocks. You have the S block right here. Don't forget this guy over here. He's a tricky one. You have the S block. You then have the P block. You have the D block. And then down here at the bottom, you have the F block. What this means is that if you have an element that has anything to do with the S block, its electrons are going to move in a certain pattern. Okay? If it's in the S block, it moves like a sphere. If it moves in the P block, or if it has electrons in the P block, it's going to move like this. It's going to kind of make a figure eight. So electrons start here, they go around, and they come back. Okay, and they go over and around, around and around and around, over and over again. If they're in the D block, it's like a crazy figure eight times 2. Okay. And then you have all sorts of things going on in the F block, many figure eights. Okay. So that's how electrons move. What electron configuration means to you is you're going to have to write out an electron configuration, and it will help you understand why atoms bond the way they bond. Okay. We put back up our blocks. Okay, and you're going to read it just like you read a book. And you are going to start here. It's a very, very bad arrow. And you're going to go across just like you read a book. This might be confusing right now, but remember, you read it just like a book. Okay? Let me give you an example. Let's look at helium. Helium is right here. Okay? You write down helium because that's what we're going to do. Its electron configuration starts right here. Oh, sorry. Its electron configuration starts right here, because you read it like a book. So you know for sure it's going to hit the 1s block. And how many times was it in the S block? 1 and 2. So you put a baby 2 up here, an exponent, and that shows you that helium has an electron configuration that has 1 ring, and it's moving in a spherical way, and there are 2 electrons. Okay, let's try another. Put our blocks back up there. Okay, now let's do boron. Okay, we are going to start here. Read it like a book and keep on going until you hit boron. Okay, boron for sure is in the 1s, and you go here, and you go here. So there's 2 electrons in that first ring that's moving like a sphere. Then you go to the next line. You're going through the 2s block, and there's 2 electrons there, and then you hit boron right here. You look, it's in the 2p block. It has 2 rings, and how many electrons? Just 1. Now here's a good way that you can check yourself. These exponents should add up to the atomic number. Boron's atomic number is 5, and you have 2 plus 2 plus 1, and that gives you 5, so you know that this electron configuration is correct. Okay? I want you to try one now. Put our blocks back up. I want you to try sodium. So I want you to pause the video on a scratch sheet of paper. I want you to write down the electron configuration for sodium. Ready, set, go. Okay, so sodium is right here. The atomic number is 11. So you read it like a book and you start up here. It goes through the 1s block. It goes through 1, 2. So the exponent is 2. Then you come to this section, 2s, 1, 2. Go all the way across. You hit the 2 p's. 1, 2, 3, 4, 5, and 6. And then you hit sodium, which is in the 3s block, but it only has 1 exponent, or 1 electron. Count up your exponents. 2, 4, 4 plus 6 is 10, plus 1 is 11. You know this electron configuration is correct. Okay, there's a shortcut to all this, but right now we're not worried about that. I want to show you how we can tell how things are going to bond just by looking at their electron configuration. If you look at the last block that we wrote down, 3s1, you know that that block's not full. Not only is that block not full, but that whole last ring is not full. It has 1 quote-unquote extra electron that it needs to get rid of. So that's why sodium gets rid of 1 electron and it has a positive 1 charge. In the PowerPoint that you're going to be watching or learning, you're going to see a lot of this electron configuration, and I want you to understand that if you look at this last chunk, you should be able to tell how it's going to bond. If the very last block was 3p5, it only needs one more electron to become stable. So it would gain an electron, and it would be a 1- charge because it's going to gain a negative charge. Make sure that you remember this whenever we go through 6.2 notes and when you do the 6.2 note-taking guide.